So last time when you computed the confidence intervals, we started with only a fixed sample size. If you would like to experiment with what type of sample size would be appropriate, the ballpark is 25 to 30 observations, but that's I mean you could use your own approximations as well. A quick way to do that is just to create a simple data frame with a range of sample size that you would like to experiment with. So I've created this array which has a range of sample sizes ranging from 10 to, let's say, 400 plus, and I can quickly create a data frame. Just name the data frame real quick, and once I do that, I'll write a custom function which invokes the t-test on a given sample size, right? So this is a sample size is the parameter which is going to vary for each invocation of this test, and then that will be passed as an input variable or input parameter of this function. So once I write this custom function that invokes the t-test for the given sample size, and then I have to invoke that using lapply so that it does it for each observation. And once I do that, I will. So let's first do this, and let's see what the values are. You can see that the confidence interval is computed for each of the sample sizes ranging from 10 to 440, and you can do a visual observation to find out which sample size gives you the sharpest confidence interval. But if you'd like to use a visual way, a quick way to do that is to extract the confidence intervals lower and higher ranges. So I've just done a simple for loop to do that, and once I come out of the for loop, I'll just do a simple subtraction to calculate the range, the higher value minus the lower value, and I will set that as a separate variable. So my data frame now looks like this, where I have the lower end of the confidence interval and the higher end of the confidence interval added as a column in the data frame. And once I have that, let's just do a simple plot which basically plots my confidence interval range versus the sample size. So this gives us a slightly, this is like familiar distribution, right? It's an exponential distribution. So we can look at the elbow, and elbow would be typically, now the problem with this plot is that the scale is not efficient, right? So I just have 0 and 100. So I know that elbow is somewhere here between 0 and 100, but I need to understand where exactly, which particular sample size I'm getting elbow at, right? So to do that, there's another function called xy plot. This is part of the different package called lattice, and then once I run that, I can see that and here I've applied the scale, right? Scale here is the exponential scale, but again we have some issues with respect to the labeling, and a simple way to counter that is just to replace this exp raised to 1 with 2. And then you can see that the elbow is somewhere here at 2 raised to 5, which is 32. So I know that maybe I will have to take sample just between 30 and, because you can see that this the difference that's between the lower and higher side of the confidence interval or the range is decreasing until this point, right? So somewhere near 30. And if I look back at the original data frame, I can see that around 35 to 40, so either sample size 30 or sample size 35 or 40, or I can even take 30. So 30, 35 and 40, those are the three possible values that give me the sharpest confidence interval. And you can also quickly do a range check on this. So I think about 48 and 48, right? So this is the range here, and for 35 it is 40. So I would take 35 as my final sample size. Again, this differs from observation set to observation set. Ballpark is around 30, but that may not be true all the time.